Today we are looking, this is Algebra 1, lesson 3.4. We're looking at solving equations that have variables on both sides of the equal sign. Notice what your goals say. Collect variables on one side and then use it to solve real life problems beginning on page 154. First thing you have is a definition of an identity. An identity is an equation that is true for all values of the variable. What that means is when you have the same variable on both sides of an equal sign. So if you have, let's say, 2x on the left and 2x on the right, okay, it's going to be a true statement. In this case, this is an identity because when you divide by 2 on both sides, you're going to get a true statement. You're going to get 0 is equal to 0. If you add anything else with it, like plus 1, if it's the same on this side, plus 1, it's still exactly the same on both sides. That's what an identity is. When we get to example number 2, you'll see what a couple of examples of those where it'll be an infinite amount of solutions or it'll be no solution. That's what an identity has, an infinite amount of solutions because it's true for all values of the variable. Example number 1 says solve 4x minus 10 is equal to 32 minus 3x. Again, notice you have a left side and a right side like normal, but now you have 4x on the left and you got negative 3x on the right. What you want to do, it says look at the coefficients of the x terms. One's 4, one's negative 3. Since 4 is greater than negative 3, collect your x's on the left side. Bring your smaller x value over to your larger one. So when you compare 4 and negative 3, we know that negative 3 is a smaller value. So bring that over to the left side. And in order to undo negative or minus 3, you add 3x. So on the next line, it's just the horizontal method again, adding 3x to both sides. What that does is that cancels out the 3x on the right side, just like as if you had did it underneath it in the vertical method. And what you're left with on the right is 32 all by itself. Now you have 4x plus 3x, which is 7x on the left-hand side, minus 10 equals 32. Since you brought your x's to the left side, or your variables to the left side, bring your constant terms to the right side. So minus 10, in order to undo minus 10, you know to add 10 to both sides. And that's the next line, again, the horizontal method, adding 10 to both sides. It cancels it out on the left, and then 32 plus 10, we know we're going to get the number 42 on the right side. So we have 7x equals 42. Then it becomes just like undoing multiplication. It's a one-step equation at this last point. Undo 7 times something by dividing both sides by 7 in order to get x's value 6. So all you want to do, bring the smaller x or the smaller variable, whatever it happens to be, over to the larger one side. Bring the other values, the constant terms, the ones that don't have a variable, to the other side, and then solve for it just like we did last week. It just becomes a multi-step equation at that point. Okay, take about a minute to do these two. Okay, let's take a look at it. I know looks like some of y'all are still working. Probably gave y'all too many problems to do all at once. So let's just focus on the one on the left for right now. Solve 6x plus 22 is equal to negative 3x plus 31. Look at your x values. One says 6x, the other one says negative 3x. Negative 3 is smaller than 6. So bring the smaller one over to the left side of the equation. Again, you have a left side and a right side. That says negative 3x, which is the same thing as minus 3x. Undo that. You know how to undo minus something by adding 3x. If you add it to the right, add 3x to the left to balance it off. We know that 6x plus 3x is going to be 9x plus 22 equals, it canceled out on the right, and we still have 31 on the right. So now it just becomes a two-step equation like last week. That's the only thing we added to this week. Undo, since we have our x's on the left-hand side now, let's bring 22 over to the other side. It says positive or plus, so subtract 22 to cancel it out. If you subtract 22 on the left, subtract 22 on the right. 31 minus 22 is going to be the number 9. This part right here cancels out, so you have 9x. Then undo 9 times something by dividing by 9. Do the same on the right to balance it out. X, since this cancels, equals 9 divided by 9 is the number 1. And then we'll quickly look at the other one. Again, I gave y'all too much at one time. Look at your W values. One of them is negative 12, the other one's 6W. Negative 12, even though 12 looks like it's larger than 6, is smaller since it's a negative value, so bring it over to the right side. Again, there's the left side and the right side. If you have to separate them, do that. Undo minus 12W by adding 12W. If you add it to the left, add it to the right. 6W plus 12W we know is 18W. It cancels the left. 64 is equal to 18W. Then it's just one step. Undo the fact that it says 18 times W here by dividing by 18, because we want to get W equals all by itself. That's what we just did. If you divide the right, divide the left by 18. And 64 divided by 18 is 4. 3, I'm sorry. There's something looked funny. 3. Here's example number 2. Notice it says many solutions or no solution. Okay. This is where we were talking about it a minute ago with that definition of an identity. This is an identity problem, one of these. A says solve 2 times 4x plus 5 is equal to 8x plus 10. This is just like the bell work. Undo this part by distributing 2 times 4x, you get 8x. 2 times 5, you get 10. Notice we get 8x plus 10. Notice what's on the left side and what's on the right side of the equation. It's exactly the same, 8x plus 10. Okay. What that means is it's a true statement. True statements, when you undo, this is just taking it to the next step. This is just undoing the plus 10 by subtracting 10 on both sides. Or subtracting 8x. I did the opposite one. It doesn't matter which one you do, but just to kind of keep it the same when you subtract 8x on both sides. You get 10 equals 10. Notice that is a true statement. It is true. Therefore, this is how you answer this question. X is equal to all real numbers. That is the abbreviated version of every real number. You just write 2 lines like that, and then on the first one you just make a capital R. All real numbers. You can write in all real numbers. That's just a faster way to do it. All values of x are all solutions, because 10 is equal to 10 is always true. The original equation is called an identity, since it's the same both on the left and the right. And that holds true, but what we said, what is the identity property? Remember the identity property, when you 8 plus 0 equals 8. That's the identity property, because it stays 8 the whole time. Its identity doesn't change. The other equation, x minus 1 is equal to x plus 7. Notice you have the same variable again, the same coefficient. Both of them are 1. On the left, it says negative 1. On the right, it says positive 7. So when you cancel out the x by subtracting x on both sides, if you just follow your normal steps, you would subtract x and subtract x. You cancel them out. You're left with a statement that says negative 1 is equal to 7. That is not true. Negative 1 is not equal to 7. Therefore, it is not no solution. And just like this was the short way to write all real numbers, this is the short way to write no solution. It is null set. That means null set. That means there is no set of numbers that when you plug them in, give you the solution. So if it's a true statement, all real numbers. If it is a false statement, null set. Okay, take about 30 seconds to do this problem. Okay, this one says 4x minus 4 times x minus 5 equals 4x minus 20. You do the same thing as before. You distribute 4 times x and 4 times negative 5. You get negative 20. Notice what's on the left and the right now. It's the same statement. 4x minus 20 equals 4x minus 20. If you wanted to follow the same steps we've been doing, you would move the 4x over to the 4x. It's positive, so you'd subtract 4x, and you do it here as well. And it would cancel this out, and it would cancel this one out, so you'd be left with a statement that says negative 20 equals negative 20. That is a true statement. Therefore, your answer to this equation is x is equal to all real numbers. All real numbers. It doesn't matter what number you plug in place of x, you're going to get a true statement. You can plug in 1, you can plug in 100, you can plug in 100,000. It's going to be a true statement. Okay? Take about 30 more seconds and do this one. Okay, another easy problem. You can see, just looking at the left and the right side of the equation, they both have the same variable 3x. It's the same coefficient. So when you cancel out, when you move one over, there is no smaller one, but when you move one of them over by subtracting 3x on both sides, that's going to cancel each one of them out. So you're going to be left with a statement that is not true. Negative 10 is not equal to negative 9 is not equal to 10. Therefore, x's value, this is how you write your answer, x's value is no solution. And again, that's just shorthand. If you don't feel comfortable writing that, write no solution for that one. Okay, these are just more complicated equations. With your more complicated equations, you are still using your normal blueprint. You're still using, please excuse my dear Aunt Sally, and when you're undoing it, you're going backwards. So right here we have 3 times 2 minus x plus 2x is equal to negative 5 times x plus 2. The original statement is here. Then distribute 3 times 2 and 3 times negative x. That gives you 6 minus 3x. And negative 5 times x is negative 5x. Negative 5 times 2 is minus 10. So all we're doing is shorten it by using the distributive property. The next thing is you want to simplify by combining negative 3x and positive 2x. That's going to be negative 1x. Now we have an equation that is simplified on both sides, but now we have to bring our smaller x value over to our larger x value side. Negative 5x is smaller than negative 1x if you need to write that in. So in order to undo negative 5x, you add 5x to both sides. When you add 5x to the right, It'll cancel it out. When you add 5x to the left, it'll give you 4x. Negative 1 plus 5 is 4. So now you have 6 plus 4x is equal to negative 10. Since you brought your x's to the left, bring everything else to the right. So bring 6 to the other side. It's positive 6. So you subtract 6. It's positive, so you subtract 6. You subtract it on the left, subtract it on the right. Negative 10 minus 6 is negative 16. Then get your x by itself. It says 4 times x. You know how to undo 4 times something. Divide by 4 on both sides. And a negative divided by a positive is going to be a negative 4. Again, this is your order of operations. Use this. We didn't learn this for nothing. Continue to use that with problems that look difficult. Okay, take about a minute to do this one. Simplify the left, simplify the right. Move your smaller x to your larger one. Move everything else to the right. Okay, a lot of us looked at this problem and we said, oh no, there's a fraction in it, and everything just shut down on you. You still follow the same procedure though. Remember, always go back to this to simplify it. For please excuse my dear Aunt Sally, you know to do parentheses first. There's nothing inside the parentheses as you're looking at them. We can't put 2 and minus x together. We can't put x and plus 3 together. So there's nothing inside the parentheses to take care of. There's no exponents to evaluate. So the next step is to do multiplication and division. We know that 10 is right next to the parentheses. That means to multiply. So 10 times 2 is going to be 20. That's just distributing. And 10 times negative x is negative 10x. Bring the rest down. Plus 4x is equal to. Now we get to the part where everybody's seen this and say, ruh-roh, I don't know how to do this part. Okay? You still do it the same way. Negative 3 times 10, you distribute it here. That's negative 3, I said times 10, negative 3 over 10x, and negative 3 over 10 times 3, it's just written just like this. Negative 3 over 10 times 3, which is over 1. That's negative 9 over 10. So negative 9 over 10. Okay. So now we have fractions that we would like to undo. We would like to cancel out fractions. Okay. Most of us would rather undo that. In order to undo the fact that this says divided by 10, we could do it now. We could cancel it out. In order to cancel out divide by 10, multiply each of the terms by 10. So that's times 10, that's times 10, that's times 10, this one's times 10, and this one's times 10. Now what that's going to do is it's going to give us larger numbers, but our fractions will go away, and that's what most of us would prefer. Okay? 10 times 20 is going to be 200. 10 times negative 10x is negative 100x. 10 times 4x is positive 40x. Okay, so again, we got bigger numbers. All we really did was added a 0 to everything. But right here, this is why we did it. Because negative 3 divided by 10 times 10 is going to cancel it out and leave us with negative 3x. Most of us would much prefer that. And negative 9 divided by 10 times 10 is going to cancel that out and leave us with negative 9. Now we got something that we can deal with a whole lot better. Combine your like terms, negative 100x and positive 40x. is going to be negative 60x when you put them together. Bring the rest down. 200 is still there. Negative 3x is still there as well as minus 9. Bring your smaller x over to your larger x side. Negative 60x is smaller, even though it looks bigger, than negative 3 because it's farther to the left. Think about a number line if you have to. Negative 3 is right here. Negative 60 is going to be way further to the left. So in order to undo negative 60x, add 60x. If you do it to the left, make sure you add 60x to the right. Negative 3 plus 60 is going to be positive 57x. Bring everything else down, minus 9. This part right here cancels. You still have the number 200 there. So now that we have 57x on the right, we want to bring the rest of it over to the left. So the rest of it is simply minus 9. Cancel that out by adding 9 to the right, add 9 to the left. 200 plus 9 is 209 equals 57x. So in order to cancel out 57 times something, divide by 57. 209 divided by 57. You're going to get 3.6 for this one. I feel like I've made a mistake somewhere, but 3.6. I'll see if I can correct it in just a minute. 3.6.